In the last lesson, Newton's laws said that if you apply a force to a mass, that mass is going to accelerate. But in this lesson, we'll look at what if you don't just have one force, but you've got another force. This is going to be dealing with multiple forces. It's really not too bad. We just got to compare those two forces, see which one is going to be bigger, and this one's going to be that top one. And overall, we're going to have an acceleration in that direction. Let's look at that in a bit more detail in handling multiple forces. Okay, so to look at multiple forces, again, let's look at how we handled one force and just a reminder of the equations with that. So if a person comes in, applies a force to this 10 kilogram mass, we apply a force, it should accelerate. The formula that we used was force is equal to mass times acceleration. Here we have a number of just 20 newtons, so let's plug that into the formula. Now I wrote it here as F is equal to ma. I know in the last one I did A is equal to F over m. That's probably a better definition of Newton's second law, but this is going to be most useful, I feel, for solving questions and especially handling multiple forces. So I'm going to write it like this, probably the rest of the chapter. F is equal to ma. So let's plug in our numbers. We have 10 for our mass, 20 for our force. We'll just divide by 10. We get 2 meters per second squared for the acceleration. Not too hard of an example. But now we'll look at the topic of this video, and really the fundamental skill for this entire chapter is how do you handle multiple forces. So now we're going to have a force this way of 20 newtons, but now we're going to have a force the opposite way of 10 newtons. Now, important to note that I put a negative there because forces are vectors. You do have to take into account direction. Doesn't necessarily need to be that to the left is negative and to the right is positive, but as long as you're consistent. So I've chosen right to be positive, left to be negative. I have to keep that for the rest of the example. If you want to flip it though, that's totally fine. Okay, so how am I going to handle these multiple forces? Well, the first thing that I've actually already done is I've put a little picture to show what forces are present. This is called a free body diagram, and it's the first place to start when there are multiple forces. Draw a little diagram of all the forces acting on the object. So we've drawn our free body diagram, force left and right. Okay, next is we're going to look at F is equal to ma, just as I showed before, but I did leave a little part out. This actually isn't just F is equal to ma, there's a little subscript, it should be F net. What does F net mean? Well, net just means like the overall force. The net force is the overall force. I didn't need to include it before, because there was only one. The force we were looking at was the overall force. But now that I have two, I should be writing that in there. The overall force will cause the mass to accelerate. So we're looking at, if I'm pulling with 20 this way and minus 10 that way, what's the overall force? All we have to do is add up the forces that are acting on this mass. So I need 20 minus 10. I've added 20 and negative 10. And my overall force would be 10 newtons in this positive direction. Now that I have the overall force, that's going to cause the mass to accelerate, divide by 10, and we're going to get our answer of 1 meters per second squared, which makes sense. It's basically like we're just applying 10 newtons this way, divide by 10 kilograms, and we get 1 meters per second squared. Now that works pretty well when the numbers are easy to work with and you can kind of just figure out the net force by looking at it. But actually, if they're a little bit tougher numbers, or maybe even have 3 forces, I would set the question up like this. F net is equal to F1 plus F2, and if there's more, F3, F4, however many there are, as a fundamental start to basically every question in chapter 3. The net force is looking at all the forces we see, add them up together. And that's not too hard of a step to do. F net is equal to whatever forces you see in the question, and it's a good place to start to make sure you didn't miss anything. Where would I go from here? Let's just see what we know. So F1 is going to be 20, F2 is going to be negative 10, F net. This is where we're going to use that formula, F net is equal to ma. I'm going to put ma right below F net because that's what F net's the same as. F1 is 20, F2 is negative 10. Now how we're going to solve it? Well, I can take my 20 minus my 10. I know this is going to be a value of 10. To solve for the acceleration, I'm going to divide by the mass. In this case, I know it's also 10. And we're going to get the same answer of 1 meters per second squared. Might seem like a little bit more work for this one, but it's going to help us a lot when we get to more complex examples. So to look at some more complex examples, we have to look at types of forces. Just so we're not using F1 and F2, we can analyze the situation and look at the types of forces that are likely to be present. So first of all, the person pushing on the box, we're just going to call force applied, FA, force applied. You could use this for anytime something's pushing on something else, like a car pushing on the ground, wind pushing on an object. We're just going to call that force applied. The force backwards in this case is from the rubbing of the surfaces. We'll do a more in detail lesson on this later, but it's called the force of friction. That's pushing it backwards. So if I look for F net is equal to a sum of the forces, F net is equal to FA plus FF. That's where I'd start any question like this. Now, it is important to note that this is looking at the forces that are going on in the X direction, the side-to-side horizontal direction. And that's good that we've just considered those, because just like we saw in chapter 2, things going on in the horizontal don't affect things going in the vertical direction. So we're going to look at our X forces. If there's anything going in Y, we'll look at that separately. So now let's take a look at what could be happening in Y. Well, in Y or up and down, any mass on the surface of Earth is going to be pulled by gravity. There's a gravitational force pulling it down. Okay. That probably appears like it's going to be the only force happening, but if that was the case, this object would fall. If you take an object and let it go, gravity should cause it to accelerate down. In this case, it's not, because the ground is pushing back up, so we need to include that force as well. We're going to call it the normal force. The normal force is a force coming from a surface, and it's always going to push at 90 degrees to that surface. A 90-degree line is called a normal line, so that's why they call it F normal here. A bit of a weird name. We're going to call that the normal force. So if I'm looking at the Y direction, my formula is going to be F net is equal to Fg plus Fn, because that's the two forces that are occurring in Y. So this whole setup is kind of how I would begin a lot of problems in this chapter 3 section of dealing with multiple forces. F net is a sum of whatever forces you see in that plane, either the X or the Y. To see how we apply this, let's take a look at solving for the normal force there. So let's go over here to start. F net is equal to Fg plus Fn. Just a reminder again, I didn't include Fa, I didn't include Ff, because I'm just looking about for normal force, which is in the Y direction. So I don't need to include friction or applied force here. Okay, how am I going to plug in to solve for this? Well, if this is what I'm not sure about, I should have information about these two. It might be numbers they give you in the question, or it could be formulas. We said before F net is equal to ma, so I'm going to plug ma in there. What am I going to do for Fg? And the force of gravity, this is going to come up a lot in the chapter, is simply the mass times the acceleration of gravity, m times g. How do we know that's the force of gravity? Well, imagine if you had that object and you just dropped it, it would accelerate at 9.81 due to the force of gravity. So that mass would be accelerating at 9.81 because gravity is pulling at that number, m times 9.81. So that's always how we're going to find Fg. So let's plug in here. We have ma for F net, mg for Fg. I'm trying to figure out Fn. So let's plug in our numbers. We know this is going to be 10. 10's the mass in both cases. This one, 9.81. A little messy, but you get the idea. But I'm kind of left with this acceleration. What is the acceleration in this case? Your first thought might be, well, wasn't it 1 meters per second to this side? That's what we solved for before. And you'd be correct, but what direction is that acceleration? That acceleration was in X. This whole question is dealing with what's happening in Y. And this is a really easy part to get mixed up on. What's the acceleration in Y? Because we're dealing with the forces in Y. When I look at this box, it was moving to the side. Was it accelerating up or down? No, it's just staying there. It's not flying off the ground. It's not sinking into the ground. So our acceleration in the up and down direction is going to be just 0. There's no acceleration in the Y direction. So that means the overall force, 10 times 0, has to be 0. So now when I plug in my numbers here, 0 is my overall force. 98.1, I'm going to call it downwards, is going to be negative. I can figure out what my Fn is. So what do I have to add to negative 98.1 to get 0? It's just 98.1. So my normal force is going to be the same here as gravity to cancel it out so it doesn't accelerate up or down. To end the video, let's look at one more scenario. This one's actually a little bit tricky, where we have a box being pulled up by a rope. So first thing, we'll look at our free body diagram, and then we'll create F net is equal to a sum of the forces. You can do that pretty for every problem that has with multiple forces. So free body diagram, gravity's going to be pulling down, something's going to be pulling up. This is going to be the rope here. And this is actually a new force we haven't seen before. If it was on the ground, I could just put normal force, but anything through a string or a rope, we're going to call the force of tension or pull in that string. Doesn't really change how we're going to solve this, is just a different letter instead of Fn. What's happening in this scenario, we're going to pull up on it and it's going to accelerate upwards pretty fast, 3.8 meters per second squared, pulling with a big amount of force, 500 newtons, and it's asking us, what is the mass? Okay, so it seems like kind of a complex problem. We've done our first step of the free body diagram. The next step, F net's the sum of the forces, and we got a formula up here. F net is equal to Fg plus Ft. Okay, regardless of how hard this question looks, these are the steps that you're going to have to begin with. Free body diagram, F net's the sum of the forces. Okay, now we're going to see what we're trying to find and what we know. So I do know there's 500 newtons for the force of tension. F net, I don't know that, but I know its formula is Ma. Fg, I don't know, but I know its formula is mg. So let's plug in some numbers there. I have Ma, mg, and Ft. I could put 500 in here. Let's just leave it right there so far. Okay, why this one's pretty hard is I'm trying to solve for mass and I see two m's. So it makes this one a little bit difficult. First thing to consider is, are those masses the same or are they different masses? Well, the mass that's accelerating is this blue one, and the mass that gravity is pulling on is this blue one. So it's the same mass, but I just have it in two places. So we're going to have to do for this one to get that to just one m, so I'm going to have to factor it out. So how we're going to factor it out is, first I'm going to bring these m's to the same side of the equation. So I'm going to minus mg from this side, minus it from this side. So if Ma minus mg is equal to force of tension. Now, although it doesn't really look like this is much better, this has put us in a situation where we can factor out the m's. So what it means is this is m times a minus m times g. Since they're both being multiplied by m, I can pull that m out. It looks a little complex with letters. Let's just maybe see how it would work with numbers from maybe a math class. So if I had the simple expression 15 minus 10, I could say 15 and 10 are both multiples of 5. So let's write them as a multiplication of 5. Well, 15 is 3 times 5, and then 10 is 2 times 5. So I can see this is 3 times 5, 2 times 5. If they're both being multiplied by 5, I can factor the 5 out by bringing it to the front and saying this is 5 times 3 minus 2. Okay, so if they're both being times by the same thing, I can pull that number out. It's called factoring. To make sure it does give it the same answer, well, we know that 15 minus 10 is 5. What's this? 5 times 3 minus 2. Well, 3 minus 2 is 1. 5 times 1 is also 5. So the expression is the same. It's just a different way to write it. So let's go back to our example. We had m times a and m times g. So similar to the 5s, if we have the same number in front, I can pull that out and say m times a minus g. Okay, that was good because now I just have one m. I'm just going to solve for that m by itself. So I'm going to divide by the a and the g, or minus g on the other side. Let's plug in our numbers because we know all of these. 500 divided by 3.8 minus negative 9.81. It's really important to take the directions in here. Minus negative 9.81 becomes plus 9.81. And so when we divide that, we get an answer of 37 kilograms for our final answer. So that's a tricky question. It can seem hard to know where to start, and that's probably the biggest thing I see with students for this section is, where do I start? What formula do I use? Start with your free body diagram where you see all the forces, and then F net is equal to a sum of the forces. From there, you know that you're going to be on the right track. You can plug things in. That's what I want to see when I'm looking on a test or an assignment for their first step. So I hope that helps you out. Thank you so much for watching this video, and I will see you in the next lesson.